Right, the last question on the Edx M2 June 2010 paper, question number 8, on collisions. Here's the question, so take your time, pause the video and continue playing when you're ready. Okay, so for the first part I've just pasted part of the question in here. It's one of these questions where they tell you the coefficient of restitution and the masses, and you've got to find the speeds after the collision. So diagrams important. A diagram before, so before the impact, we've got A has got a speed u like this, and this one B has got in the opposite direction with a speed u, and the speeds after I'll just call v1 and v2 like that. So we've got two equations as usual. Conservation of momentum, principle of conservation of linear momentum to give it its correct name, gives us 3mu minus mu equals 3mv1 plus mv2. Then Newton's experimental law, quoting it in the form v2 minus v1 equals minus e times u2 minus u1. That will give us v2 minus v1. The speeds after collision is minus a half times the speeds taken away in the same order before. Being careful with the signs. So minus a half times the speed of b before is minus u minus the speed of a before. Right. So the top equation gives us 2u equals 3v1 plus v2. The bottom equation gives us v2 minus v1 equals u. u equals v2 minus v1. So a pair of simultaneous equations to solve. By subtracting them, we'll get rid of the v2's. So we've got 4v1 equals u. So v1 is u over 4. And v2 is u plus v1, so v2 will be 5u over 4. And that's 7 marks for that. While we're here, let's just look at the mark allocation for that part of the question. For the 7 marks, there was an M1A1 for the conservation of momentum equation, and also an M1A1 for the Newton's experimental law, or the restitution equation. That's 4 marks out of 7. And then there was a method mark for solving the simultaneous equations, and 2 accuracy marks for the 2 answers, for the velocity of A and the velocity of B. On to part B of the question. Part B, simple little one, just for 2 marks. Find the speed of B immediately after hitting the wall. So B goes on and hits a smooth vertical wall. Here's B travelling with a velocity of 5u over 4, hits the wall is fixed, and E is 2/5. So nothing else to write down really. The velocity after, as it bounces off the wall, will be 2/5 times the velocity it had before. So that gives us u over 2. Okay. So the velocity of B as it bounces off the wall is just B equals u over 2 for 2 marks. Now I've got room on the next page for this part C, but let's just read it for a minute. The first collision occurred between the first collision between A and B occurred at a distance 4a from the wall. The balls collide again t seconds after the first collision. We've got to show that t is that. So this is all about working out times and distances. Let's first of all work out the time it took. I'll do it on this page here. Time for B to reach wall. Well, B was travelling at the speed of 5u over 4, and the wall was a distance 4a away. So 4a divided by 5u over 4 gives us a time of 16a over 5u. That's the time it takes for B to reach the wall. In that time, A has moved A was going at a speed of, looking back at the last page, A was going at a speed of u over 4. So A has moved a distance of u over 4 times this time, 16a over 5u. And that's a distance of 4a over 5. Okay, so that's it, useful information. I need to go to the next page to get some more room now. I'll jot those values down again here. So, the distance apart. After B hits wall. A has moved a distance of 4a over 5. Okay, we just worked out that on the previous page, and they were 4a from the wall. So the distance apart immediately after B hits the wall is 4a minus 4a over 5, which is 16a over 5. Nearly there. Now, this distance then is 16a over 5. How long will it take before they collide again? Well, the relative velocity, the velocity that are effectively closing on each other, I'll call it the relative velocity, since that's what it is, will be u over 4 plus u over 2. And the time then will be 16a over 5 over 3u over 4. That's what u over 4 plus u over 2 is. Just don't want to lose you at all. So 16 over 5 over this closing velocity, the velocity that they're closing on each other, or the relative velocity. And that time is 64a over 15u. That's a 4. Now, is that the answer? Let's just read the question again. The balls collide again t seconds after the first collision. No, that's the time it took for them to cover the distance that they were apart. So the total time is 64a over 15u, which we've just got there, plus the time it took for B to reach the wall, which was 16a over 5u. So the total time is 112a over 15u, which is, yeah, that we're trying to show that, 112a over 15u. So rather a scrappy little last part of the question, but it did carry 6 marks. Let's just go back and put the mark allocation for parts B and C. For part B then, to get the speed u over 2 there, to find the speed of B afterwards, I think it was just 2 marks, wasn't it? So it was B marks, basically 2 B marks, B2. And then for this last part, for the 6 marks for that, well, there was M marks for working out the times, M2, A2, for working out these times. and just going to the last page here. For the last, there was another A2 then presumably for this last part. A2 there. So that's your 6 marks for part C. Okay, and that's the end of the June 2010 M2 paper from Edx.